All right, question 10 asks us to identify the scientific tool that we would use from our word bank for each of these procedures to determine whether or not a substance dissolved in water will conduct electricity. We saw some videos of that. That would use a conductivity probe. Right? To measure the mass of a substance after it has gone through a physical change, we measure masses with an electronic balance. Question C. Heat a sample of wet, solid substances to get rid of the water, to dry it out. We can use a hot plate to heat things up. Question D. Measure the exact amount of water to add to a solution to dilute it. There are lots of things that measure water up here, but to get exact measurements of water, we need to use a graduated cylinder. And finally, to add exactly 10 drops of water to a solid sample to see if it will dissolve in water, the only thing up here that does drops is a dropper pipette. Question 11 asks us to make conclusions about two different mystery substances. They were put through the same test that we used to figure out the properties of covalent and ionic compounds, and we need to figure out what they are. So mystery substance 1 has a pretty low melting point, poor solubility, meaning it doesn't dissolve in water very well. It doesn't conduct electricity as a solid or a solution. That matches, right? Not conducting electricity, doesn't dissolve, low melting point, that matches our covalent compounds. Mystery substance 2, high melting point, 250 degrees, really high, it's above 200. It dissolves in water, it has good solubility. It doesn't really conduct electricity as a solid, but not much other than metal does. And then it's a good conductor of electricity in a solution. So if it dissolves in water, it does conduct electricity. This matches our properties of ionic substances. Now we need to provide a justification for our conclusions in the space above, or in the question above. So, substance 1, I'll just say number 1, is covalent because it matches the properties of covalent compounds. And we can say the same thing for number 2, but instead of covalent, we'll say ionic. Number 2 is ionic because, B/C means because, it matches the properties of ionic compounds. Right? Remember, covalent compounds, low melting point, bad solubility or poor solubility, and poor conductors of electricity in a solution. Ionic substances, high melting points, good solubility in solution, good conductors of electricity in solution. All right. A couple more questions here. Number 13 asks us to make measurements on our graduated cylinder and triple beam balance and metric ruler. And we'll put those measurements in this table. So graduated cylinders, remember we need to figure out what these minor markings mean. Here we've got 10 and 15 and 5 spaces, so each marking means 1. Here's 10, 11, and 12. We go past 12 and up to not up to 13. So it's 12 something, right? 12 something. Those are our certain digits, the ones we can see the lines for, the ones we know. We have to estimate between the lines. We have to guess at the next digit between there. That looks about halfway, so I'm going to say 12.5 milliliters in our graduated cylinder. Our triple beam balance is part B. We have to add up these beams. Right? 700 plus 10 is 710 plus 3. We can see that 710 plus 3 is 713. We can see 0.1, 0.2, 0.3, 0.4, right? 713.4. But it doesn't look like that line really makes it to 0.5. So 713.4. Those are all our certain digits. We can see all of those, right? See 0.1, 0.2, 0.3, 0.4. You have to include all the numbers for the lines, and then we guess between lines. That's probably halfway between 0.4 and 0.5, so I'm just going to add a 5 there. 713.45 grams. And then we do our metric ruler. Same thing. We need the certain digits, all the lines that are actually on the measurement. We go to 3, and then we have 10 spaces to get to 4. So each one of these lines is 0.1, 0.2, 0.3. Right? We make it to 0.4, so 3.4. But it looks like that line is slightly past 0.4, not anywhere near 0.5. So I'm going to add a number that's between. So since it's less than halfway, I'm going to add a number between 1 and 4. I'm going to say 3.4. 2. I'm going to add my uncertain digit of 2. Uncertain digit here, halfway. Uncertain digit there was halfway.